Hello, we are the Double-Shear Fastener Strength Fixture team. I'm Caleb Beard.
I'm Stephen Brooks.
I'm Bennett Kerr.
And I'm Thomas Reichle.
And our sponsor is Parker Lord. For the background on our project, a previous research team performed research here at Penn State Barron in collaboration with Parker Lord. The team designed and utilized a clevis lug test fixture to perform double shear test on high strength aerospace steel bolts. The testing was based off of axial gaps between the clevis plates and the lug. The team was testing for the strength of the bolts as the axial gap was increased. However, upon testing, they realized at high axial gaps, the bolts would fracture and get stuck in the test fixture, and therefore require machining to remove the bolts from the fixture.
The objectives of this design are to improve the current design of the two-plate shear testing mount. They are to allow that the mount should not need to be sent to the machine shop in order for the bolt to be removed. This was an issue during previous testing because the bolt would get stuck in the fixture, and when they sent it to the machine shop, it would increase the lead time dramatically between tests. And the mount should not only allow for axial variation, as was before, but it should also allow for radial clearance between the two designs.
We came up with multiple choices for a redesigned fixture, but ultimately we came down to these three designs shown here. The first one being the bisectional design, where the clevis plate is split vertically in half. We came up with a horseshoe design where a top portion of the plate will slide out and the bottom will stay mounted in the fixture. And we also came up with the clamp design, where we would have a lead screw in the bottom to fasten the specimen bolt into the fixture. We narrowed it down to these three designs because they showed promise of high strength in a tensile test and ease of removing test subjects.
And ultimately, our final design choice came down to the bisectional plate. This design was determined to have the highest potential in terms of strength, ease of manufacturing, and most effective method of releasing the test subjects. With this mount, we could take off only the front plate, slide out old test subjects, and slide in a new one for ease of replaceability, and significantly lowered the lead time in between tests from days to minutes.
Here's an assembly of the mount with the new design. Very similar to the original design. However, it has the modified clevis plates and an accompanying modified lug design.
So the method that we used to collect data once we had a fixture manufactured was by testing these bolts under 4 different radial clearances. These different radial clearances are common in industry. The different radial clearances would be achieved by having bushings inserted into the clevis of different sizes, with the same size bolt being added. Each radial clearance had 5 different samples tested. We ended up normalizing the data of the fractured force, and the data was normalized in order to show more accurate trends by dividing the force at which it was fractured by the ultimate strength of the material times the cross-section, times 2. The gap was normalized by dividing it by the bolt diameter.
So the results that we got from our testing is that the bolt fracture force decreases by about 1,000 pounds, going from a radial clearance of 0.0009 to a 0.1 clearance. And what we also found was that the deformation in the lug bushing increases as the radial gap size increases.
Here we will show you a video of our mount in action. Thank you. That is our project.